Yes, my students, the new topic that is gravitation. Under gravitation, gravitational potential energy. Okay, you know that you have learned in the ninth standard about the potential energy. Here I am going to tell you its definition again. The potential energy. Here I am going to write definition. Potential energy. Now see what's its definition. It is energy stored in an object. It is energy stored in an object due to its position or state is called potential energy. Is called potential energy. Okay, this is the definition. It is energy stored in an object due to its position or state is called potential energy, and potential energy is represented by mgh at for an object of mass m and at height h from the surface of the earth. Okay, now see here, I am going to explain it. The potential energy due to the earth gravitational force. Now see here, I am going to draw a figure regarding it. Explain the potential energy. Now see here, suppose this is your earth. Suppose this is your earth. Now, if an object is at a height h from the earth, if an object is at height h from the earth, its potential energy will be given by mgh, where m is the mass of the object. Okay, and potential energy on the surface of earth is considered as 0. Okay, because this height will become 0 here. Okay, now see, if we are going to take this object up to a height which is equal to infinite, or up to a greater height, what will happen? The value of g will going to decrease and it will reach up to 0 as the force of attraction of earth goes on decreasing. Its acceleration due to gravity will also decrease, and then what happened? The value of mg at infinite will be 0. It means that the value of potential energy, here it is 0, here also it is 0. It means that this value of the potential energy should be considered as 0 and this value of energy is considered to be negative. Means the object at height h, its potential energy will be negative or minus mgh. Okay, that I am going to explain here. Now see, first point, it is assume that the potential energy of an object of mass m at height h from the surface of Earth will be equal to mgh and it is 0 on the surface of Earth. This is assumed, okay, that its potential energy is 0 at the surface of Earth. Now see, I am going to explain that as we move as the height h is increases, as the height h increases, the value of g decreases. Now the third, for larger height, that is at infinite, the value of g will be equal to 0. Therefore, it is more appropriate to consider, to assume potential energy zero there. Now it means if the potential energy is 0 here, potential energy is 0 here, it means at height h this potential energy must be negative. Therefore, the potential energy of an object of mass m and at height h at height h will be equal to mgh. Now see here, in your textbook it is given as the potential energy is equal to minus g m small m upon r plus h. Here I am going to write here this in this form, that is, now see, you know that acceleration due to gravity is given as r square. Okay? Now for the height h, this small m, g will become capital M. Here r square, because at height h, this will be r plus h square, and for h, here it will be from the center of earth, it will be r plus h. Therefore, this r plus h will cancel, it's one power, it will become m g capital M upon r plus h. Therefore, this will be minus g capital M into small m upon r plus h. This is given potential energy at height h from the surface of earth in your textbook. Okay, understood? The next topic will be your escape velocity. Yes, the next topic is escape velocity. Okay, we are going to write its definition now here. Writing the definition, it is minimum velocity, minimum initial velocity, required for an object to escape from the earth gravitational force of attraction. It is a maximum initial velocity required for an object to escape from the earth gravitational force of attraction. Okay? Now see here, according to Newton third law of motion, according to third law of motion, V square is equal to U square plus 2AS. Now, if an object is thrown upward, then what happens? Its final velocity V become 0, and the acceleration A will be, because throwing upward, will be minus G. Substituting these values here, U square plus 2 here minus G as, that is U square minus 2G, yes. You can say that U square is equal to 2Gs. Okay, where S is the displacement, or you can say it is the height. Means therefore U square is equal to here 2G. Instead of yes, I am writing here H, because S is equal to H in height. Now see here, it will be U square upon 2G is equal to H. It means the maximum height depends upon the initial velocity. This shows that the maximum height depends on the initial velocity. Therefore, here in definition it is given that the minimum initial velocity required for an object to escape from the Earth's gravitational force of attraction. Now see here, one derivation is given here. What will be the escape velocity? Okay. Now see, on the surface of Earth, the kinetic energy will be equal to half young V escape square, and potential energy will be, as I told you, minus G capital M small m upon r. Therefore, the total energy on the surface, total energy on the surface, suppose it is E1, is equal to kinetic energy on the surface plus potential energy on the surface. Okay? Understood? Now I am going to write the next, that is E1 is equal to kinetic energy half mv escape square minus g capital M small m upon r. Okay, now the kinetic energy of the object at infinite, that is kinetic energy at infinite will be 0 and the potential energy is equal to minus g m upon infinite, that is also equal to 0. Therefore, the total energy at infinite is equal to potential energy. Consider this is equal to E2 is equal to kinetic energy plus potential energy at infinite. Therefore, this E2 is equal to 0. Now the total energy of an object on the surface is this one, and at infinite is E2 is equal to 0. But as per the law of conservation of energy, as per the law of conservation of energy, E1 should be equal to E2. Therefore, it will be how much? Half v escape velocity minus g capital M small m upon r is equal to 0, and you can write half m escape velocity square is equal to g capital M small m upon r. Or we can write here v escape velocity. Here m will cancel, is equal to 2 g capital M upon Now you know that G is equal to Gm upon R square. Means if I am going to multiply here by R in the numerator and in denominator, therefore here V escape is equal to 2 G R, or we can say the escape velocity is equal to under root 2 G R. It does not depend on the mass of the object. Now, where G is the acceleration due to gravity, substituting the value, and here R is the radius of the earth, 6.4 10 raised to 6. Now, after calculation, it will be 11.2 kilometer per second. Now, this is the escape velocity required for an aircraft to overcome the Earth's gravitational force of attraction. Therefore, for a spacecraft, the initial velocity should be greater than 11.2 kilometer per second to overcome the Earth gravitational force of attraction. Means by this you will see that if we want to launch a spacecraft, it should have the minimum initial velocity 11.2 kilometer per second, so that it can overcome the Earth gravitational force of attraction. Okay?